A dehumidifier is an appliance that extracts water from the air around it. One particular dehumidifier operates at 230 volts AC and has a power rating of 0.35 kilowatts. A. State the fuse rating that should be used for this dehumidifier, and B. Calculate the resistance of this dehumidifier. Now, when it comes to fuse ratings, there is a rule. If the appliance has got a power rating of less than 750 watts, we choose a 3 amp fuse. Now, our appliance has got a power rating of 0.35 kilowatts. Multiply that by 1000 and you get 350 watts. 350 watts is less than 750 watts, so we choose a 3 amp fuse for this appliance. Now we're asked to find the resistance of our dehumidifier. Now to do that, we have to use a formula. Now if you note, we're told the operating voltage is 230 volts, and we're also told its power rating 0.35 kilowatts. So if we look at our formula sheet, we'll identify a formula that includes all three, and that's P is equal to B squared over R. That's one of the formulas for power. Put our values in, solve it for R, and we have got a value for our resistance. Notice in the solution that I've included the units every step of the way through. That's okay, but you don't have to do that. You'll just include the units at the end. So when you write down your value for your resistance, always include the unit, otherwise you'll be marked out. Also, at the very beginning of the problem, write down the formula you're using and you'll get a mark for that. Part C. The dehumidifier switches on automatically when the moisture in the air increases above a certain level. This causes an LED to light and a fan to turn on. Part of the circuit diagram for the circuit is shown below. And there we have the moisture sensor and the variable resistor that will constitute the input device. We have a transistor, that's the process device, and that's the transistor in this case is acting as a switch. The output device is a fan circuit and also an LED, a light emitting diode connected between X and Y. And there is our electronic circuit. 1. Complete the circuit diagram to show the LED connected correctly between X and Y. Now we're asked to connect an LED, a light emitting diode between X and Y. Now an LED, like all other diodes, are polarity conscious. This means we have to connect them to the circuit the correct way around. So what's the rule? Well, an LED's got two parts. It's got the anode and it's got the cathode. The thick bar at the bottom indicates the cathode. Now the rule is this: the cathode always has to be connected to a lower potential than the anode. So if there's a circuit with a battery, the cathode is facing the negative side of the battery. If you put it into a circuit like this, the cathode is facing the lower potential, which in this case is 0 volts. Two, the voltage across the moisture sensor decreases as the moisture in the air increases. Explain how the circuit operates to turn on the LED when the moisture in the air increases above a certain level. So how does the circuit operate? Well, we're told that the voltage across this moisture sensor decreases when the moisture in the air increases. So how does the circuit operate? Well, you've got to know this one simple fact. If the voltage across the moisture sensor is decreasing, necessarily so, the voltage across the variable resistor must increase. To give you the full story behind this, which I think is important, I produced this very short clip to help you understand what's going on here. So there we have a block diagram for the general electronic system. We've got an input that's sensed by an input device, which will send a signal to the process device, and that in turn will send a signal to the output device, and there we will have our output. That's a general electronic system. Now, For our particular electronic system, for our dehumidifier, the input is the moisture from the room. That will be sensed by the moisture sensing circuit, which will send a signal to the transistor switch, which in turn will send a signal to the extractor fan with the indicator LED, and we will have as an output a dehumidified room. And this is our moisture sensing circuit. It's simply two resistors in series forming what we know as a voltage divider. There's a moisture sensor, which is represented by resistor R1, and there's resistance R2. Now, it's important to note here that the signal that goes to the transistor switch, that is the voltage across resistor R2. V out is the signal, and that's the voltage across resistor R2, and you must always remember that. That's the voltage that gets processed by the transistor switch. So when the signal produced by the moisture sensing circuit is high enough, the transistor will switch on the LED and fan. If it's too low, it won't switch on. And there we have our formula for working out our voltage output, our signal. And that is the voltage of the source multiplied by R2 divided by R2 plus R1. And that follows directly from Ohm's law. But this is the way we write it when we're discussing electronic input devices that are formed by voltage dividers. And also, you also must note that at all times the voltage across R1 and the voltage across R2 have to add up to Vs. So VR1 is equal to 6 and VR2 is equal to 2. Vs has to be equal to 8. And if VR goes all the way down to 1, then VR2 must go all the way up to 7. Because you always must have the same sum. And there we'll have a table of some examples. Now suppose all the resistors R1 and R2 are the same, then our signal is 3 volts. But if R1 goes up to 4 kiloohms and R2 stays at 3 kiloohms, then the voltage signal falls. And you can verify that using the formula. And similarly, if R1 goes down to 2 kiloohms, then our signal goes up to 3.42 volts. So you can you can see the pattern there. And if R2 is fixed, it says, then the output signal increases when R1 decreases and vice versa. Summary sheet part 3. Explain the purpose of the variable resistor in this circuit. Well, this allows us to control the switch on and switch off point.